Hi viewers, welcome to my channel. In this lecture, we will discuss about RDD features. In previous session, we have discussed about uh, introduction to RDD. What is RDD? Resilient distribution data set, how it will be created, and other stuff we have seen in previous session. And in this session, we will discuss about RDD features. There are six important features of RDD. First one is a fault tolerance, distributed. Third one is lazy evaluation, immutability, in-memory computation, and capability of handling all types of data. We'll see one by one. First one, fault tolerance. Once in a data RDD, once you loaded some file, once RDD is created, if you perform some transformations, okay, RDD will be whatever based on whatever logic you have written, that lineage graph will be formed. Okay, Spark keeps a record of lineage while tracking the transformation on the that have been performed. Okay, what are all the transformations you are performing on RDD? That the lineage graph will capture the uh, status. Okay, lineage graph will be formed based on that transformation logic. Any part of RDD is lost, then Spark will utilize the lineage record to quickly, efficiently recompute the RDD. Okay, in between something transformation is in progress, something data is lost. Okay, again RDD will Spark will utilize the lineage graph to recompute the okay to recover that loss. Okay, how it will track? So it will identify the it will track that lineage graph, and where data is lost, it will identify and it will recover that data. Okay, so RDD tag the lineage transformation, lineage information to recover the lost data quickly and automatically and failure at any point of execution cycle. That is called a fault tolerance. Means if something in between data is lost, because why fault tolerance is important? Source, when you read data from the source into as a RDD, it will be distributed, distribution framework, right? Data will be evenly distributed across the cluster. Okay, source to target, always it should match. Okay, while for example you are reading 1 GB file, it will be divided into, for example, 5 partitions. When you sum that 5 partitions, it should be equal to 1 GB. So if it is not matching, means data lost. How we can recover the data? Using fault tolerance. Fault tolerance feature. Fault tolerance and what it will use? It will use lineage graph. It is very important interview question. What is lineage graph? Okay. We'll go to the next feature, distributed. RDD will be divided into partitions while data being processed. Each partition will be processed by one task. So in the architecture, I have explained all these points. One partition will be processed by the one task. The default block size of Spark is 128 MB. We can change the size if required. Config file will be there, usually in Hadoop. If you are dealing with a huge cluster or huge data, they can change block size also. 128, 156 also, 256 also we can change. So we can control the number of partitions while reading the input files itself. Okay, this is I will explain in while creation of RDD. Okay, these are the few important points in the distributed feature. Spark is a distributed in-memory computing framework, right? So when whatever data you are processing, that will be distributed, okay, divided based on the block size, and it will be distributed across the nodes of the cluster. This is the second feature. For example, 500 GB 500 GB file you are processing. That 500 GB, sorry, 500 MB you are processing. So 500 MB RDD, how it will be divided? So block size is 128 MB, right? So partition 1, it will be 500 MB, 500 divided by 128. So we can consider it will be divided as represented in the diagram. Partition 1 128 MB, partition 2 128 MB, 3 128 MB. Partition leftover 116 MB will go to the fourth partition. Like that, it will be distributed in the cluster. And uh, part just each partition, in one of the points we have discussed, each partition will be processed by one task. Okay, one executor. That is nothing but this partition one will be uh, executed by task one. Partition two will executed by task two. Okay, these tasks will be executed in the worker node one in one by the one executor. Like that, remaining two partitions will be divided as task 3, task 4, and these two tasks will be executed by the work executor in the worker node 2. Like that, in different nodes, this partition data will be divided, and each partition will be processed at different node by the different executors. Okay, this is about distributed feature. If you see this example, you can clearly understand, right? 500 MB file you are processing, it will be divided into four partitions. Okay, and that four partitions will be, you can consider as a four tasks. Each task will be processed by the executor by the in the different kernels. Third point is lazy evaluation. So lazy evaluation means in the Spark, we will perform Spark or Databricks will perform two kinds of operations, that is nothing but the transformations and the actions. So what are the transformations available, what are the actions available, we'll see in upcoming videos. And so all these transformations are lazy by default in the Spark. That means until you perform some action, it will not execute. So transformations, so all the transformations by default lazy. That's why it is one of the important feature in the Spark. Main advantage of lazy evaluation is the performance, because so some your complex business logic you are writing on RDDs. Okay, when you are implementing that performing transformations, only DAG will be created. Okay, DAG will be created. DAG will be created while performing transformations on the RDDs. Once action is performed, then only actual execution will take place, and DAG will be converted to physical plan. Okay, so for example, step one, you are reading one data RDD. Step two, you are creating one more RDD. In step three, you are joining these two. Okay, after that is also transformations. Fourth step, after joining that, you are seeing that count RDD dot count. So for example, you given count. Now count is an action now. So first step, second step, third step. Okay. These are these three steps we call as a transformation. These when transformations are being executed, so it will not take much time. That is not actual execution. Internally, one graph will be formed. That we'll see in separate session. We'll see practicals. In practicals, we'll see how DAX will form on this from the Spark UI. Okay. So whenever action is performed, that is main execution. Then only that logical plan will be converted to physical plan. That is called a lazy evaluation. Okay. So in Scala, uh, in variables can be lazy, right? If you declare variable with lazy keyword, that means lazy keyword what it will do. If you are declaring variable as a lazy means until unless you call that variable, that allocation of memory will not happen to that particular variable. This is the third feature. And fourth feature, immutability. RDDs are immutable by nature. Means once you create, you cannot modify. Any operation that modifies an RDD actually creates a new RDD with the modified data rather than modifying the original RDD. Okay. This is a fundamental characteristics of RDD in Spark that enables their scalability, parallelism, and fault tolerance. So immutability, it is a very, very important question in the interviews. What is the immutability in Spark? So RDDs are data frames by default immutable by nature. Immutables means once you created you cannot modify. That is the meaning of immutable. Mutable means we can modify. But data frames and or RDDs by default immutable. Once you create, you cannot modify. Rather, you can create a new RDD from the existing RDD. Like that, you can modify. But base RDD, you cannot change. That is the one more important feature. Okay, so using this feature, so it enables the scalability, parallelism, fault tolerance. Okay, this is the fourth feature, immutability. Fifth one, in-memory computation. RDDs will be stored and processed in RAM instead of disk. It avoids the read-write time and efforts on each transformation. So why Spark came before Spark? There is no in-memory computing concept. So whenever you do some transfer business logic implementation, okay. For example, if you take Hadoop, what is the algorithm inside is MapReduce, right? MapReduce, what it will do for every step, that intermediate result will be for every transformation. Intermediate results will be saved into the disk instead of memory. So reading, writing to the diskette, it will take a lot of time. So it's Hadoop always slow only. You have, if you are a Hadoop developer, you may know this point because if you write any Hive query in Hadoop cluster, even though if you just select star from some column name equal to some, for example, select star from department, select star from EMP where department number 10 means it will take 2 minutes. Okay, so because intermediate results will be stored in the disk, reading writing from the disk it is slow. So that's why to avoid this, we are so Spark is invented. Okay, Spark is a in-memory computing framework. So RDDs will be stored and processed in RAM instead of disk. So it avoids the read and writes time. Okay, in-memory computation is always fast when compared to the disk processing. Okay. Hadoop is a disk processing. Here also, not all transformations will be memory computation. Some, whenever data is shuffling, some disk operations also it will involve here. So sixth feature is using RDDs, we can handle or we can process all types of data like structured, semi-structured, and unstructured. Structured data means structured data means CSV files, TSV files, all these things. Semi-structured means text files. Semi-structured means JSON. This kind of files. Unstructured means text files. All any kind of data. We have APIs. We can process any type of data using the RDDs. We have all APIs. This is the sixth point. First one is fault tolerance. Second one is lazy distributed computing, lazy evaluation, in-memory computing, okay, and immutability, and all types of data. It can handle all types of data. So now these are the six important features. When to use RDDs? Okay, when to use RDDs means there is a three scenarios: working with unstructured data, If you don't care about schema or structure of data, don't care about optimization and performance. First point, working with unstructured data. So unstructured data, if you want to process structured data, it is fine. It is like a header with the data. It is clearly like a table. Easily we can process. Okay. But when to use RDD means, so for example, you have unstructured data like text file is there, some text is there. You want to analyze the data. For example, Twitter is there. Twitter messages are there. Some, for example, in Twitter messages, the text message is there. Some 100 GB file is there with the text. You want to identify what are all the repeat words, number of words repeatedly using. That scenario is how to do. Okay, you read that CSV file, RDDs will be formed. So whenever you are processing unstructured data, that time you will create a, or you can go for RDDs. And the second point is, if you are not comparing schema or structure of data. So text file, for example, text file schema will not be there. Okay, header data will not be, header columns will not be there, right? So such scenarios we can go for the RDDs. And don't care about the optimization performance. By default, RDDs are very slow when compared to other ecosystem like data frame datasets. We'll see when discussing about data frames. In data RDDs, there is no any optimization techniques used. Okay, and performance is a bit slow only RDDs. So this is the these are all the five features of RDDs and when to use RDDs. So limitations are now we go for limitations. When we cannot use RDDs, we cannot optimize the RDDs. Okay, we need to write more lines of code to perform simple transformations. Okay, these are the some. There is no optimization techniques. So, for example, one program is taking 1 hour, you cannot reduce the execution time. You cannot optimize that code. And next one is coding looks like, for example, you are using Spark with the Scala. It looks like Scala code. Okay, it will be very complex and number of lines will be more. Okay, you have to write in like usually in Spark Scala, we'll write when develop the business logic using object oriented style. First main method, then class, inside that methods. Okay, all these things, it looks like a pure Scala code, and the lines of code will be more. And if you want to learn RDDs, you should know one of the programming language, Scala, Java, Python, okay, to perform the operations on a RDD. So these are the limitations. We cannot optimize. Number of lines go is more. We need a programming knowledge is required to perform operations on a RDD. Okay. In next session, we will discuss about other RDD operations. Okay. Thanks for watching.